Hi guys, today we're gonna be talking about another one of the most commonly asked tech interview question. Hi guys, it's your guy Odumde, and today we're gonna be talking about another one of the most commonly asked interview question. Hi guys, it's your guy Odumde, and today we're gonna be talking about another one of the most commonly asked tech interview question. If you have not been following us, do well to follow, do well to like, do well to comment and share. Today we're gonna be considering the linked list loop problem, also called the linked list cycle. And the problem statement says, given a singly linked list, determine if it contains a cycle. A cycle will occur if a node's next pointer references an earlier node in the list, causing a loop. Now we are given an example linked list. So we see that this linked list actually forms a cycle, although not immediately. Right here, the node 0 is connected to node 1, which is connected to node 2, node 2 is connected to node 3, node 2, and sorry, this is not to node 2. Right here is node 4, although there's nothing wrong if it is node 2, since there are two different nodes with the same value. So but this is node 4 right here, and this is node 5 right here. So we see that even though node 2 is connected to node 3 and node 3 next references node 4, node 4 references node 5, but we see that node 5 references a previous node in the linked list, and that forms a cycle, because when it references a previous node, this previous node still references to 4, still references 3 to 4 to 5 to 2, and then it forms a cycle right there. So the output is true, really, because it contains a cycle. A straightforward solution to this problem is to traverse through the linked list and keep track of nodes that have been previously visited in a hash set. So we keep track of 0 in a hash set, each node that has been previously visited, and whenever we come across a node that have been previously visited, as we traverse through the array, just like now when we come up to 5 and then we look into the next attribute of 5, we see that it has already been previously visited and it is in the array, it is in the hash set, and because of that we are gonna return false. But if we can iterate through the whole array without getting to null, actually iterating through the whole array and getting to null without encountering a previously visited node in the hash set, definitely it is not a cycle, it doesn't contain a cycle. So but looking at this now, it's gonna take us linear time to iterate through each node in the array, and then it's gonna take us an extra space of on space that will be used to store the previously visited node in the hash set. So can we come up with a more efficient solution that will run in a constant space, that we use a constant space? So meaning that we actually want to come up with a more efficient solution that won't require us using a hash set to store previously visited nodes. Let us imagine a racetrack that is represented by a circular linked list, that is a linked list with perfect circle. So where we have two runners, the fast runner and the slow runner, you understand, one runner will win eventually. So we have two runners that are running around a racetrack that is represented as a circular linked list like this. Fine, both of them will start at the same starting point, at the same node, you understand, and we would observe that if they both move at the same pace, let's say that they move at one step at a time, they move right to from starting point to point 1, and then they move at the same step, at the same proportion to point 2, then point 3, point 4, and the rest of them like that. So we realize that at any point in time they are gonna be at the same position, at the same node. But let's consider a situation whereby the slow pointer right here is moving one step at a time, but the fast pointer is fast enough to move 2 steps at a time, meaning that right from this starting point the fast pointer jump to this node 2, while the slow pointer jumps to node 1. One thing we will notice is that the one way or the other, the fast pointer is gonna overtake the slow pointer eventually, because the track is circular. It's just like running a marathon. It will overtake the slow pointer. Now, how is this gonna be of useful information to solving this problem? One thing about linked list is that, to identify when the fast pointer overtakes the slow pointer might be quite difficult. To detect that might be quite difficult. Why? Because there's no positional indications. There's no indices, unlike array whereby there's indices. But one thing that can give us a better clue is that the fast pointer, at some point in time, the fast pointer is gonna reunite with the slow pointer, and they are gonna meet at a node. You understand? They are gonna meet at the same position, and so that can give us a better clue that this is a cycle, because once they start at the same position, and peradventure after cycling, the fast pointer taking 2 steps at a time and the slow pointer taking a single step, if they should meet, definitely it is circular. Because imagine now, if it is a linear linked list, they will never meet. The fast pointer is gonna definitely get to the endpoint, to the last node, far before the slow pointer, at least 2 times faster than the slow pointer. But if they should meet at a node, definitely it is a circular linked list. So that is how we're gonna be solving this problem. Right now, the problem, the question now is the fast pointer gonna meet up with the slow pointer someday, or will it continuously overtake and bypass the slow pointer? I think it's a good idea if we look into that matter and not just come into a conclusion. Let us consider this example whereby 2 runners, the fast pointer and the slow pointer, are trying to run in a perfect cycle. Perfect cycle is actually a circle, or that is represented by, or a linked list that is represented by cycles, entirely cycles. If you look into our example right here, you see that, well, it's not a perfect cycle, though it's also the linked list forms a loop, a cycle, but it is not perfect because right from here it was linear just before it got to this point and become circular. So, but right now we're gonna be considering perfect cycle because we don't know. They can decide to give us any one of the 2. So let's consider the case for a perfect cycle like this. And now we have our fast pointer and our slow pointer on a perfect cycle. So let's see if they're gonna meet. Looking at this point, they start here, and the slow pointer move 1 step to the node 1, fast pointer move 2 steps from the node 0 to node 2. And looking at this, that's one iteration. You understand? Another step again to take is that the slow pointer move from 1 to 2, while the fast pointer, which is already at 2 before, move to 4. You understand? So right now the fast pointer is at 4, slow pointer is at node 2. So then let's look at the next step. Is right here. The next step is down here. So it's right here. So we see that from node 4, or let me say from node 2, that the slow pointer is, it moves to node 3, while fast pointer move from node 4 to node 1. So right then, from 3, the slow pointer, another iteration, it moves to node 4, while the fast pointer moves to node 3. You see, from node 1 it moves to node 3, and then the slow pointer moves to node 0, while the fast pointer moves also to node 0, and you see that they eventually meet here. So this shows that in a circular linked list, you understand, if the fast pointer is moving twice as much as the slow pointer, they are definitely gonna meet, and definitely we are gonna find out that it is a circular linked list, or at least it forms a loop. So now we're gonna be considering a situation whereby we used to call it the delayed circular linked list. Why? Because it is delayed. It first look linear before it then form circular. So let's consider a situation whereby we have the fast runner and the slow runner in a linked list that doesn't form a perfect circle, just like the example given to us. So right now they start here at the same position. Now the fast pointer moving 2 steps forward is gonna move to 2, while the slow pointer moving 1 step forward is gonna move to 1. The fast pointer then move 2 steps forward to this point 4 here, right here, while the slow pointer move from 1 to 2. So similarly, the fast pointer is gonna move from 4 to 2, but now the slow pointer is moving from 2 to 3. So, and right here, don't forget that fast pointer is at 2, slow pointer is at 3, and now the slow pointer moves to 4, the fast pointer moves to 4 as well. Right from 2 it takes 2 steps forward to 4, and then they eventually met. In both cases, it will look like as if the fast pointer and the slow pointer will never meet, but that is not the case. Let us clarify why they met. We see that in each iteration, the fast pointer is moving 2 steps forward, while the slow pointer is moving 1 step forward. So the fast pointer, is taking 1 step, is actually covering the distance of 1 node over the second pointer. It's just like when something moves at the same position, or let's say that the fast pointer is trailing the slow pointer, for instance, now, and then the fast pointer is 2 steps away from the slow pointer. We see that after 1 step, the fast pointer gets 2 steps forward, the slow pointer gets 1 step forward. So that means that there's high probability the distance between the fast pointer and the slow pointer now boils down to 1. You understand? Just like in this case, look, fast pointer is at 1, slow pointer is at 3, and the distance between them is 2. So now fast pointer comes to 3, slow pointer comes to 4. Why? Because it's moving 2 times faster than the fast pointer, and before you know it, the fast pointer slow pointer gets to 0, and the fast pointer meet up with it. So that's why they will always meet for a circular and even a delayed circular linked list. So now let's consider a situation whereby the linked list does not form a cycle at all. So don't forget that the problem statement asks us to return null if it doesn't form a cycle. We see that if it doesn't form a cycle, we still have to place our fast and slow pointer at the head just to traverse the array. And then you see that the fast pointer is gonna keep moving 2 steps forward, slow pointer is gonna keep moving 1 step forward, and before you know it, the fast pointer is gonna get to null earlier before the slow pointer, and then we are gonna return false because it has gotten to null, and then at the point where it gets to null, it can't proceed anymore. We have traversed the entire array. So what I'm trying to say simply is that if we can traverse the entire array without getting the fast pointer and the slow pointer to point at the same node, that is, without getting them to be equal to each other, and then we are able to traverse the whole array and get to null without these two pointing to each other, definitely no cycle is present. So but in a situation whereby we traverse the array and then the fast pointer and the slow pointer points to each other, definitely there's a cycle there. And don't forget, the cycle means that we are not getting out of the loop, so immediately we return true. So it's 2 conditions: let them meet. If they meet, return true. If they do not meet and they exit the loop, if they do not meet, definitely they're gonna exit the loop someday. So, and we're gonna return false. So we're gonna be going to the code implementation, but don't forget to like, comment, share this video, because it's gonna be doing me good. It's gonna be doing you good as well, because your hiring manager, recruiters, and employees, and your friends in your top tech companies, your mentees, are actually gonna see you share this video. They're gonna see you engage the video, and they're gonna approach you someday. All right, thank you. All right, let's go into the code implementation now, guys. So we're gonna be defining our list node. So the list node is a class that will represent our nodes. So right now it's gonna be taking guess value and then the next attributes. So you don't have to send in this next attributes. In fact, you can just send in value. You understand? So you just set the next attribute as a manually right here. So you can set value equals to value, meaning that one thing that we are collecting for sure is the value. You understand? So whenever I want to create a node, we are going to pass in the value, whether 1, whether 2, whether 3. So, and we can now define the next attribute right here. You understand? So the next, and set it to none by default. You understand? We can do it this way. It's quite straightforward. So, and after this, we're going to be defining our function. So don't forget the function linked list loop. So it's gonna be taking in the head node. Don't forget, what we need is the head node, which is also a list node because it's a node. So, and then define, we're going to be returning a boolean value of whether true or true or false. So let's pass as first, because I really love to define the parameters we're going to be using. So if you look at the diagram that is below, let me make it actually like this, and then let me put it smaller so that it will not cover the code. So we have the node 1. We are going to be defining the node 1, and this simply how we define node 1, list node of 1. So similarly, we are going to be defining node 2, node 3, node 4, node 5. So node 1, this is node 2 right here, and right here we have node 2, and this node 3 right here. Okay, node 3, and node 4 right here, and node 4, and node 5 right here, and node 5. So don't forget that. So let's connect this node. The next attribute of node 1 goes to node 2. You understand? We're trying to convert diagram into code now, that visual diagram. So the next of node 2 also goes to node 3, and the next of node 3 will also go to node 4, and similarly the next of node 4 will also go to node 5. Now the next of node 5 will go to node 2, because that is where the this thing occur, the cycle, the loop. So you see how simply we just do it. So fine, we can just try to print linked list loop of node 1, you see. And right now let's go into the code implementation. We're going to be having two runners, don't forget. So let's call it the runner slow and the fast runner, and these two runner will be situated at the head. They're going to start at the starting point, so which is the head. So what we now do is that while fast runner and fast.next, this one is trying to ensure that it has not gotten to the end node, or let me say last node. Don't forget that for a last node, the next attribute will definitely be none. You understand? So that is if it is a linear. Don't forget, in a circular linked list, we're not even gonna get to the last node. You understand? But this one is particularly for a last node. So whenever it has gotten to none, whenever the last node is a none, definitely we just wanna skip it. We just wanna break the loop and do some other thing. So while fast and fast.next is assuring us that we are not getting to the last node, and what we want to do is that we want to shift our slow right now by one step. So we are assigning the same slow to its next. So why? Because we are trying to shift it by one step. So similarly, our fast now, we're gonna be shifting the fast by one step. You understand? Sorry, now by two step. you understand? Because it's moving 2 times more than the slow pointer. So now we are gonna be checking if slow is equals to fast, meaning that if they get to a point whereby they reference themselves, don't forget that for a circular they always get there. So and at that point we wanna return true because we found that it is a circle. So but in a situation whereby it exits this loop without returning true, that is, it is able to exit this loop, the fact that it can exit this loop means that it is not circular, because for a circular it can never exit. It will only get to a point whereby they will be equal and it will return true. But in a situation whereby it is a it exits, definitely we are returning false, because it's enough flag to tell us that yeah, this is not circular, because a circular you can't exit a loop like that. So and then similar, this is simply what you have to do to solve this problem. You see, logic and understanding. So let's run the code. Yeah just like how code is, code to be so there's one error, it's a simple syntax error that we have here. Instead of putting comma, you have to put equals to. It's equals to that is supposed to be here. So let's run it again. So yeah, quick one. This is the quick answer right here. It's not really difficult, is it? So and this is the true right here, this is the true right here. So, and then the problem is solved. The linked list loop problem is simply solved. So thank you. Don't forget again to subscribe, to like, to share, to do anything to promote it. So because it's really helping me, and it's really helping you to get that your next tech interview. It's far more than just understand. It's about visibility. It's about, you understand, people seeing you doing it, people seeing you engaging this content, people seeing you, hiring managers seeing you. It's now more than resume and tech stack. Is about being out there. That's what make you distinct. That's all the difference. So thank you and take care.